Hi. Now, that leads us to understanding correlation ID, logging, and tracing. That we we have to consider these things very important because in this is my experience, and I have seen in many design is never considered important. I have seen many documentation that they forget about to mention how to use correlation ID and what to do and the what information has to flow across the systems. So we need to think about these things. So let's talk about one of the most important topics in enterprise integration, which is observability. And the three key components that I already mentioned, that correlation ID, logging, and tracing. The correlation ID is a unique identifier assigned to every transaction or request that flows through your system. And think of it as a tracking number for a parcel. It is generated, it travels with the message as it passes through API management, logic apps, service bus functions, and even downstream systems like Salesforce or Workday. And the beauty of this is that it let you trace one business transaction across multiple services, no matter how distributed and the architecture is. Now, there are different types of correlation you can apply. Request correlation tracks the request correlation is that tracks a single API call or logic app run. Session correlation that groups a series of related requests like a batch of employee updates. Then we have parent-child correlation, connects sub-processes to a main transaction. For example, APIM calls a logic app, which in turn sends a message to service bus and triggers an Azure function. So having the same correlation ID throughout this chain is what enables a true end-to-end visibility. So that's very important. Now, now next is logging. Logging is simply a recording what's happening. But in integration, how you log matters. I mean, there should be a structure. So you want your logs to be structured, preferably JSON, centralized in application insight or log analytics, and always include that correlation ID. So if you are logging message in Azure function, you need to make sure that correlation ID is part of that structure. Now there are various kind of logs of basically four main types. System logs, right, generated automatically by Azure resources like Logic Apps or Service Bus. Then we have application logs created by your own code, functions, or workflow to track custom operations. Security logs record authentication attempts and access control events. Then we have business logs that capture domain events like employee onboarded or invoice process. So there are many kind of logs you can think about. Now the third one is final one is tracing. So I already talked about little bit about these things. So tracing is when while logging tells you what happened, tracing shows you how it happened. Means it will tell you every second event. So it tells you the entire journey of the request across systems. In Azure, we use distributed tracing, which is built on W3C trace context standard, and it has two headers make this possible. One is trace parent. This carries a trace ID, span ID, and that uniquely identify the transaction and the current operation. All right. Then we have trace state. This adds vendor-specific metadata for deeper insights or cross-platform correlation. As the request flows from APIM to Logic App, this is an example, Logic App to Service Bus and functions, these headers are automatically passed along. Application Insight then uses them to build a trace map through every dependency, calls and timings and all those stuff. So you just need to, if I, in summary, if I say correlation ID connects every component, logging records the facts at each step, and tracing visualizes the full story. So we need all three in every case. All right. So let's take an example here. Okay, let's take a real world scenario. Real world scenario. An employee in this scenario, an employee onboarding is like an employee onboarding process. When HR adds a new hire in Workday, it triggers a webhook to our Azure API management endpoint. Okay, APM accepts the request and logs it, and it attaches a correlation ID. So we now have correlation ID when it comes to Azure. A unique identifier, either, okay, there could be two scenarios. Either Workday can provide us, or we can create ourselves in APM. So a unique identifier that will travel through every system involved in this transaction. It also adds a transparent header so that distributed tracing can follow this transaction end to end. So the request flows into Logic App from there, APM to Logic App, and this ID passed to Logic App, which orchestrates the onboarding steps. It creates a record in Dynamic 365 HR, sends a provisioning message to Service Bus, and also raises a ticket in ServiceNow for the new laptop. The service bus message includes the same correlation ID, so it's passing, from Logic App to service bus. And so when Azure function picks up to create the employee's Active Directory account, it logs its logs are automatically linked to the same transaction. I mean, we have the same ID flowing through. If sometimes something fails, say the service ID service now API is down, that error is logged with the same correlation ID. And when you open application insight, just search for that ID, and you have the entire story. We tell you what happened. Application Insight builds a distributed trace starting at APIM, and then Logic App and Service Bus and the function, and the final service now. This is how correlation ID, logging, and tracing come together to make an integration completely observable, turning a complex cross-system process into a single traceable system. So it is important that we implement it properly. Okay. Okay, demo, I will not give you demo in this video, but I will create a separate video from end-to-end observability in a system, and I'll use the system I described in my example. I'll use all those systems, and I'll show you in a demo that how it can be done. So I will include Workday, I will include Salesforce, and these systems, and I will use Logic App, Azure Function, Service Bus, and other important systems. So you will have a very good idea how it works. Okay. So now, from the best practices point of view, we must design system for observability. We should not ignore it, because if we do not have these things, this tracing and monitoring, all those things in place, it is always a problematic. I mean, we need to have a logging properly. We need to have correlation ID. We have tracing properly, so that helps us to debug issues quickly. Otherwise, we just lost. So and I have seen many challenges when we don't do this thing correctly. Uh, Logging best practices. So when we log, we need to make sure that we have structured logging like JSON ideally, and that must include correlation ID. And it should capture both technical details and business context, because we need to know what happened, what business context we're talking about, and technical details, error code and whatever. So those need to be there. So those are the important thing. Could be, I don't know, might be, for example, from business context point of view, you can have for example, employee ID, invoice number, whatever, those information should be there. Now, that what are the best practices for tracing? Tracing best practices are enable distributed tracing everywhere possible. Azure already supports the W3C trace context standard, so we just need to enable it. If not enabled, APM automatically attaches them. Logic App standard propagates them, and functions and service bus can record them. So if you're using application inside, it should be easy to log these things. So make sure that we log the correlation ID everywhere. Matrices and alerts. So in this scenario, logs and traces tell you what happened. Matrices tell you how well it's happening. The track key matrices like execution duration, failure rate. We discussed earlier MTTR and all those things. Message backlog and SLA uptime. Set We need to set alerts, alert rules that notify the right people automatically, and those alerts to alerts to run books or logic app that can attempt self-healing actions. So we need to make sure that we create alerts thoughtfully, because it is also possible that alerts start sending messages and they overwhelm the support team. So we need to be very careful when we create alerts. It should not be randomly, should be very thoughtful. Um, and also replay messages like from DLQ. So how once something is in DLQ, how to process it. We need to think about those things as well. And we know that in a continuous improvement, it's not a one-time thing. We need to make sure that we keep track of everything we have done so far, and we need to make sure that we can improve it. So if we can't do documentation properly, it's always very difficult to track it and to improve it. So make sure that we have done documentation properly. So what is next? So I will create a demo video on observability implementation, how to design a dashboard as well, because that's fine so far. We have implemented a correlation ID. I mean, we have implemented tracing, we have implemented logging, matrices are there. But the question is how to view those things, matrices, how to create a dashboard. So I had a module in my MBA, analytics for managers. So I will leverage that learning in order to create a dashboard, and I'll give a how to give a I'll provide a video so you can also look at how to design a good dashboard, means that can be helpful, not just information but how we organize the information on the dashboard. That's also important. All right, thank you very much for watching the video. I hope you have learned something in this video, and please give your comments, and I'll try to improve because I'm very new to it. I'm just